Hey everyone, this is Mr. Couple. In this video, I'm going to be teaching you about vectors and scalars. The way it works is in physics, every quantity is either a scalar or a vector. Scalars are quantities that just have a magnitude or a size, but vectors also have direction. So vectors have magnitude and direction. This subtopic will provide you the tools you need for dealing with vectors. Let's use our prior knowledge to make a list of as many scalar and vector quantities as we can. So pause this video and fill in this table. Here's a list of scalar quantities and vector quantities that I came up with. Maybe you had some of these same ones. Scalar quantities, I put mass, length, time, energy, volume. None of these quantities, if you were to measure them, would have anything to do with direction. You wouldn't need a compass to measure these quantities. It doesn't matter what direction, if it's north, south, east, west, time doesn't care. North, south, east, west, energy doesn't care. But for vectors, they do care. If you push something up, it's going to accelerate up. If you push something to the right, it's going to accelerate to the right. So these quantities do point. Velocity points, force points, acceleration points, displacement points, electric field points. These quantities have direction associated with them. And so that's why they're called vectors. All right, let's test down here. So what about weight? Where would you put weight? The equation for weight is W equals mg, which is weight is the mass times the acceleration of gravity, or the gravitational field strength. Well, gravity, the gravitational field, that is a vector. Mass is a scalar. So if you take a scalar and you multiply by a vector, you're going to end up with a vector. We're going to say that weight is the force of gravity. Mass times acceleration is a force. Weight is the force of gravity. And so since force is a vector, weight is also a vector. So weight has a direction. The direction of weight is always down. Your weight is pointing down towards the center of the planet. Okay, let's look at density. Similar to this, density is the Greek letter rho, so that's spelled RHO, so / rho, to get it in the equation editor, is mass divided by volume. Density is a ratio of the mass of an object to its volume. So density is the ratio of mass to volume. Since mass and volume are both scalars, density is a scalar. Mass and volume, neither one of those are vectors. They're both scalars. Mass and volume are both scalars. So if you take a division of a scalar by a scalar, you're going to end up with a scalar. Momentum. The equation for momentum is P equals mv. In this case, you have a scalar times a vector. So again, momentum is going to be a vector. So momentum is a product of mass and velocity. Let's try typing that correctly. Since velocity is a vector, momentum is also a vector. Let's move it down so it's nice, looking nice on the line. And then lastly, we have temperature. The equation for temperature is complicated. I don't feel like giving it to you guys in this video, but we're just going to say that, hey, temperature is not a vector. So temperature is a scalar. It has nothing to do with direction. You wouldn't say, oh, the temperature today is 80 degrees north. That doesn't make any sense. So that's why temperature is a scalar. It has nothing to do with direction. Okay, moving on. Let's talk about how we visualize vectors. Vectors are represented graphically with an arrow. The length of the arrow gives the magnitude, and the arrow, the way it's pointing, so like the angle, gives the direction of the vector. To say that two vectors are the same means that both magnitude and direction are the same. Vectors do not have to start at the same point to be equal. We write vectors as bold, italic, A. The magnitude is written as absolute value of A or just A. So you notice that when it's a vector quantity, we write it in bold, but when we're just saying just the magnitude, we write it in italics. So most of the time when you see equations in this class, they're just going to be regular old italic letters, meaning that they're just dealing with the magnitudes. It says state the magnitude and direction of each vector below. Okay, for this vector, we want to state the magnitude and the direction. The magnitude of this vector is 2 units. So I'm going to go out of the equation so I can go to a text box so I can write U because I don't want it to be italicized. And then it's going to be comma. And then we're going to put the angle or the direction. So the way that works is to the right is 0 degrees. So I'll show this to you guys on the drawing here. So if we went straight to the right, this direction would be 0 degrees. And so if we go straight up, then that would be a 90-degree angle there. So this vector points 90 degrees. So 90 degrees means north. So I'm going to come down here, insert an equation, type 90 degree, and then line it up like that. And then I'm going to close off the brackets. So that's my vector notation. So bracket 2, and then I had to go to text box so that the unit wasn't italicized, put the comma, put the direction, and then close the bracket. So that's the process we're going to use for the rest of these. We may find it helpful to copy these annotations. So if I hit, I'm going to select all these annotations. It's probably Command. So hold down Command and click, and we'll select all of them. We're going to hit copy and then hit paste, and it will paste it down. So now I can just come in here and I can just edit this, and it's much easier than having to type all of that in again. Okay, this guy, well, this one is already pointing to the right. So I can just edit this last one here and just make it a 0. It's 2 units because the length is 2 boxes. So 2 units at 0 degrees. And we'll do the same thing. We'll select these annotations again. Holding down Command and clicking, hit copy, hit paste, drag it down here. And now we're going to have to figure out what this guy is. Well, this one's a little bit trickier. So on this one, we actually have to do a little bit of math. Actually, it's the Pythagorean Theorem. So we know that the base of this triangle is 2 units. And the height of this triangle is 2 units. Actually, you know what? We could draw straight lines. If you hold Shift and then click, it will force you to draw a straight line. So both of these are 2 units. So we've got 2 units this way. We've got 2 units this way. And this is a right angle. Let's call this side of the triangle A. And then I can write an equation that says A squared must be equal to 2 squared plus 2 squared. So that's just applying the Pythagorean theorem to this right triangle. Well, 2 squared plus 2 squared, that's just 4 plus 4, that's 8. And so I know that A squared is going to be equal to 8. So A, therefore, is the square root of 8. So I'm just going to come down here to the 2. I'm going to pull it out because I know I've got to do a little bit of work here. So the first thing I'm going to do is I'm going to take the square root, so SQRT space, of 8. But realize that the square root of 8, that's just 4 times 2. And the square root of 4, well, that's 2. So really what I have here is 2 root 2. So then I'm going to drag this back down here and line it up with the rest of it. The angle is not 90 degrees. You have to think, well, what is the angle of a square? What's the angle that this makes right here? And so note that this is one of the special right triangles from geometry. This angle is 45 degrees. And so I'm going to change the 90 to be a 45 degree. And so now I'm done. You know, it kind of looks gross that it's not lined up. So maybe I'll just select all these annotations and then move them in so that it's lined up and it's nice and centered on there. I don't think I need to do that for all of them, but this one in particular, since it did get a little bit wider that way, just make it look nicer. Okay, there we go. That's a little bit about vector notation. So the way you state a vector is you give the magnitude and you give the direction. If you just give the magnitude, it's not a vector. You have to give the magnitude and the direction for vector quantities. Let's look at this question number 4. The picture shows 3 vectors, A, B, and C, on an XY coordinate plane. State which vector is the greatest and justify your answer. So pause this video and go answer this question. At the same point to be equal. They just have to have the same magnitude and direction. Vectors A, B, and C, they each have magnitude 2 units and point to the east. Hence, vectors A, B, and C are the same vector. Remember, we talked about this earlier. You can translate a vector. You can move it around however you want to. That won't change the vector. But if you multiply it by a scalar, that can actually change the vector. So check this out. When we multiply vectors by a number, you're going to change the vector. So this vector A, here's what it looks like when you multiply it by 2. It gets 2 times longer. And here's what it looks like when you multiply it by negative half. It gets half as long, and it actually flips to go in the opposite direction. So let's look at this. So in vector notation, vector B is 2 units at 90 degrees. This means vector B has magnitude 2 units and points north. On the grid below, draw and label the following vectors: negative B, 2B, negative 3B, and half B. All right, so first, we know that vector B is 2 units at 90. So let's draw vector B first. So I'll come down here to my drawing tool, and I'll choose red. I've actually set up a custom palette here, so I clicked more colors, and I set up my colors to be red, blue, green on the top row, black, white, purple on the middle row, and then yellow, magenta, and cyan on the bottom row. You can set your palette that way or set it however you want to. I like to choose high contrast colors for the top 3 slots so you can see them really good on this white background. All right, so I'm going to go to the drawing tool. I'm going to choose red, and I'm going to draw this vector B, 2 units at 90 degrees. So here we go. So I'm going to go 2 units. So starting here, I'm going to hold shift, and I'm going to click, because when you hold shift, it forces it to be a line. As long as you hold down shift, and I'm going to go 2 units north, put my arrow in there, and label this as vector B. So what's vector negative B? Well, vector negative B would also have 2 units, but instead of pointing north, it would point south. So I'm going to go to the same point, hold shift, click, go down, label that. This is negative B. So 2B would be 2 units, which would be 4 units. So I'll start down here, and I'll go up 4 units. There's 1B, there's 2B. And so that is vector 2B. If I want to draw negative 3B, well, I know I'm going to have to go 2 units. So I have to go 6 units. But the negative means that I'm going to be going down. So I'll start up here, and I'll go negative 1B, negative 2B, negative 3B. And so that vector is negative 3B. That negative sign was way too big, negative 3B. And then lastly, half B. Well, 1B was 2 units. So half B will just be 1 unit. So I'll just click to the same point where I had B here, right here. And instead of going up to 2, I'll go half as much to here. And that is 0.5B. Okay, now I want you guys to go answer question 6 over here. Vector C is 3 units at 180. On the grid below, you're going to draw vector C, 2C, negative 1.5C, and 1/3 C. And I'll see you guys back here in a little bit. So pause this video and come back. Here are the answers that I put for question 6. So we got vector C, which is 3 units at 180. 180 degrees is due west. Then I did 2C, which is just 1, 2, 3 times 2. So it's 6 units, points in the same direction as C. Negative 1.5 points in the opposite direction. So instead of pointing west, it's pointing east. And 1.5 of 3 is 4.5. 1, 2, 3, 4.5. And then lastly, 1/3 of C, 1/3 of 3 is 1 unit. And so it's going to point 1 unit in the same direction as C, which is to the left. Now, all I want you guys to do is to come down here and answer this final question. Reflect on your current understanding of vectors and scalars. Briefly write about what you have learned. And I'll see you guys back in class for this synchronous session.